Now moving to the eighth question. If the non-parallel sides of trapezium are equal, prove that it is cyclic. Now moving on to the solution. Let us consider a trapezium as shown in figure. Let us name the vertices of the trapezium as A, B, C, D. Here, let us assume that opposite sides are equal, those are non-parallel. That is, AD is equal to BC. So, let us draw a line CE parallel to AD so that AECD forms a parallelogram. As it is a parallelogram AECD, we can say that opposite sides are parallel and are equal. Here we can say AD will be parallel to CE and also AD will be equal to CE. But we know that AD is equal to BC from given. Therefore we can say that BC is equal to CE. Now here we can say triangle BEC is isosceles since the opposite sides, two of the sides in the triangle BEC are equal. Now in a triangle, angles opposite to equal sides are equal. Therefore here we can say that angle CEB is equal to angle CBE. Now if we consider angle CEA and angle CEB, these two form a linear pair about point E. We know that sum of angles in a linear pair is equal to 180 degrees. Here we can say that angle CEB plus angle CEA is equal to 180 degrees since these form a linear pair, and we know that sum of angles in a linear pair is equal to 180 degrees. That implies instead of angle CEB, we can write here angle CBE plus angle CEA is equal to 180 degrees. Now let us represent the angles. That is angle CBE is this angle plus angle angle CEA is this angle. Now if we consider in parallelogram AECD, we can say that opposite angles are equal. Therefore angle CEA is equal to angle ADC. But here we get angle CEA is equal to angle ADC since AEDC is a parallelogram. In a parallelogram, opposite sides are always equal and opposite angles are also equal, which implies angle CBE plus angle ADC is equal to 180 degrees. Here if we observe, sum of opposite angles in a given trapezium, that is angle B plus angle D, is equal to 180 degrees. Therefore here we can say that given trapezium ABCD is a cyclic, because we can say a trapezium or a quadrilateral is cyclic if sum of opposite angles is equal to 180 degrees. Moving on to ninth question. Two circles intersect at 2 points B and C. Through B, two line segments ABD and PBQ are drawn to intersect the circles at AD and PQ respectively. Prove that angle ACP is equal to angle QCD. Now moving on to the solution. Here he has given two circles intersecting at the points B and C respectively. Through B, line segment ABD is drawn and PBQ is drawn to intersect the circles at A, D, P and Q respectively. Now prove that angle ACP is equal to angle QCD. Let us represent the angles, that is angle ACP is equal to angle QCD, which we need to prove. In order to prove this, first let us consider the circle 1. In the circle 1, we can say that angle ACP will be equal to angle ABP since these are formed by the same arc AP. We know that angle formed by the same arc will be always equal. We can equate that angle ACP is equal to angle ABP. Let it be as equation number 1. Now again, let us consider the circle 2. In this circle, angle QCD, in the circle 2, angle QCD is equal to angle QBD. Let us name it as equation number 2 because here angle QCD and angle QBD are formed by the same arc QD. Now, if we consider at point B, angle ABP and angle QBD are vertically opposite angles about point B. Therefore, that will be equal always. Therefore, here we can equate angle APB is equal to angle QBD since they are vertically opposite angles about point B, which will be always equal. Let us name it as equation number 3. Now from 1, 2 and 3, we can say that angle ACP is equal to angle ABP. But here we got angle ABP is equal to angle QBD. But from equation 2, we have angle QBD is equal to angle QCD. Therefore, finally we can say from this equality, angle ACP is equal to angle QCD. This is what the proof we required and it is hence proved. Coming to the 10th question, if circles are drawn taking two sides of triangle as diameters, prove that point of intersection of these circles lie on third side. Now moving on to the solution, let us consider two circles about the sides of triangle as diameter as shown in figure. Let the circles be 1 and 2 and they are about the sides of triangle ABC about vertex A. One of the point of intersection is vertex A and let the other point be D. We need to prove that D lies on BC. Now let us join AD. Now this triangle ABD is lying about the semicircle of the first circle. That is, angle in the semicircle is equal to 90 degrees. Therefore, angle ADB is equal to 90 degrees. Similarly here, angle ADB and angle ADC form a linear pair. Therefore, here we can say that sum of angles that form a linear pair is equal to 180 degrees. Angle ADB plus angle ADC is equal to 180 degrees, which implies angle ADB is 90 degrees plus angle ADC, let us find, that is equal to 180 degrees, which implies angle ADC is equal to 180 degrees minus 90 degrees, which is 90 degrees. Therefore, we can say that circle described about AC as diameter must pass through point D. That is, circle described about AC must pass through point D. As angle ADB plus angle ADC is equal to 180 degrees, we can say that B, D, C lie on same line. Therefore, we can say that D lies on the third side of triangle, that is BC. Coming to the 11th question, ABC and ADC are two right angles with common hypotenuse AC. Prove that angle CAD is equal to angle CBD. Now moving on to the solution. Let us initially draw a triangle ABC, a right angle triangle with AC as hypotenuse, and next he is also given that ADC is also a right angle triangle with the common hypotenuse AC. Therefore, let us consider point D somewhere so that ADC forms a right angle triangle with angle D is equal to 90 degrees. Therefore, from the figure, we can write that angle ABC is equal to 90 degrees and as well as angle ADC is equal to 90 degrees, and both these triangles have AC as common hypotenuse. Now we know that in a right angle triangle, if we draw a circumcircle, then circumcenter will lie about the center of hypotenuse. Let us name the circumcircle center as O, which is midpoint of hypotenuse. Therefore, if let us describe a circle about AC as diameter, then we get it touching through B, D and C, since it is the circumcircle. Therefore, here we can say AC will be the circumdiameter and circle passing through points A, B, C and D is the circumcircle. Let us join BD. Now we can say that points A, B, C and D are concyclic since they are lying on the same circle. Now let us consider angle CBD and angle CAD. These are the angles formed by the same arc, that is CD. Therefore we can say those angles will be equal. That is, now here angle CAD will be equal to angle CBD since they are the angle formed by same arc CD. Therefore we know that angle formed by the same arc will be always equal. Coming to the 12th question, prove that cyclic parallelogram is a rectangle. Now moving on to the solution. Let us consider a cyclic parallelogram as shown in figure. Here let us consider a cyclic quadrilateral ABCD. Therefore, in a cyclic quadrilateral, we know that sum of opposite angles is equal to 180 degrees. Let us say angle B plus angle D is equal to 180 degrees. But in a parallelogram, we know that opposite angles are equal. We can say here angle B is equal to angle D, since opposite angles of a parallelogram are always equal. Therefore, let us substitute here that angle B is equal to angle D. Then we get angle D plus angle D is equal to 180 degrees, which implies 2 times angle D is equal to 180 degrees, which is nothing but angle D is 90 degrees. Therefore, we can say that angle B is equal to angle D is equal to 90 degrees. Therefore, a parallelogram with one of the angle is equal to 90 degrees is nothing but a rectangle. Therefore, here we can say that given cyclic parallelogram, that is ABCD, is a rectangle. Therefore, we can say that cyclic parallelogram is always a rectangle.